Hey everyone, and welcome. Today, we're going to talk about a service that is, honestly, one of the secret weapons in cloud architecture: message queues. Specifically, we're diving into Amazon's Simple Queue Service, or SQS. We're going to see how this really simple idea can completely change how you build your apps, making them way more reliable and ready to scale. Let's jump in.
So let me start with a question that probably hits a little too close to home for a lot of us. Are your application services, well, are they too codependent? You know what I mean? Your web server has to process an image upload. So it takes the image, resizes it, slaps a watermark on it, and then saves it. But what happens if that image processing part is slow? The user is just sitting there staring at a loading spinner. That, right there, is the classic sign of a tightly coupled system. And that leads us right into our first section: breaking the chain. You know, if you come from a more traditional background, maybe working with big monolithic apps and relational databases, this idea of one service calling another and just waiting, that's the default. It's how we were all taught to think. It's simple, it's direct, but it also creates a very, very fragile chain. So think about what happens when those different parts have to talk directly. If one of them gets busy, or let's be real, if one of them crashes, the entire system can just grind to a halt. If that image processor service is slow, the web server is stuck waiting. And if the web server is waiting, your user's browser is stuck waiting. The failure of one tiny piece can literally cascade and ruin the whole experience for everyone. Okay, so on this slide, you can see two totally different ways of thinking about this. On the left, you've got that synchronous request. The client sends it, and then it's just stuck. It's blocked. It literally can't do anything else until it gets a response. That's your tight coupling. But look at the right, the asynchronous message. The client sends a message and just moves on. It's free. It doesn't need an answer right away. It just trusts that the message was sent. And that is the key to a decoupled world. So how do we actually get that asynchronous model working? Well, that brings us right to section 2, where we're going to unpack the solution: the message queue. This is the magic ingredient. It's the buffer, the middleman that sits between our services and lets them talk to each other without having to be directly connected. You might be asking, okay, so what is a message queue in plain English? Honestly, just think of it like a shared to-do list for your application, or maybe a digital mailbox. One component, we'll call it the producer, writes a task on a sticky note and drops it in the mailbox. Another component, the consumer, just checks the mailbox whenever it has a free moment, picks up the next note, and gets to work. And the most important part, the producer never has to wait around to see if the consumer is busy or not.
And this is exactly where Amazon SQS comes into the picture. SQS is AWS's version of this whole concept, and the two most important words on the slide are fully managed. What that means for you is that you don't have to set up servers, you don't have to worry about maintenance, you don't have to figure out how to scale this thing. AWS handles all of that, all the annoying heavy lifting, so you can just focus on what matters: sending and receiving your messages.
The whole flow is this really simple 3-step dance. First, a producer, like our web server from before, sends a message. It could be something like, hey, process this image. Second, SQS grabs that message and stores it really safely across a bunch of different servers so it won't get lost. And third, a consumer, our image processing service, comes along when it's ready, pulls that message from the queue, does the job, and then tells the queue, okay, I'm done with this one. Okay, that's the theory. It sounds good, right? But how do we actually make one of these things? Let's get our hands dirty. In section 3, your first SQS queue. To get started, AWS basically gives you 3 main doors you can walk through. First, there's the AWS Management Console, which is just a website with buttons and menus. It's perfect when you're just starting out or exploring. Second is the Command Line Interface, or CLI, which is awesome for automation and scripting. And third, which is where the real power is for developers, is doing it programmatically, using SDKs or software development kits in your favorite language, like Python. For our first one, we're going to take the easiest path, the console. It's literally just a few clicks, but you're going to have to make one really important decision when you create it. Do you want a standard queue or a FIFO queue? Standard queues are the default. They give you massive throughput, but they don't promise your messages will be processed in the exact order you sent them. FIFO queues, that's first in, first out, do guarantee the order, but they're a bit slower. Honestly, for most situations, standard is exactly what you need. All right, so we have a queue. It exists in the cloud. Now the real fun starts. It's time to actually use it, to send it stuff and get stuff back. So let's get into section 4, talking to the queue with some code. So now that our queue is waiting for us, let's send it a message. We're going to use Python and Amazon's Bodo 3 SDK, which is pretty much the standard for this. And check out how simple it is. These two lines are all it takes to get connected. You just import the Bodo 3 library, and then you create what's called a client, telling it, hey, I want to talk to the SQS service. That's it. Okay, let's send that first message. You just call the send message function on that client we just made. It really only needs two important things: the queue URL, which is the unique address of your queue, and the message body. That's the actual content you want to send. Right here, we're just sending a simple hello there. Of course, sending is only half the battle. Now we need a consumer to go pick it up. And the code for this looks, well, almost exactly the same, which is nice. We just call receive message, and again, all we have to give it is that queue URL. This is us telling SQS, hey, go check that specific queue and see if there are any messages waiting for me. So SQS sends back a response, and tucked inside that response is our message. We can grab the body, and there it is, hello there. But now, and listen up, this is the most important step. After your code successfully processes the message, you have to tell SQS to delete it. You do this using a unique receipt handle that comes with the message. If you forget this step, SQS will think something went wrong, and it'll make the message visible again for someone else to process. Deleting the message when you're done is the golden rule. It's non-negotiable. So we've sent a message, we've received it, and we've handled it correctly. It might seem pretty basic, right? Well, let's wrap this up by connecting that simple action to its huge potential in our final section. What's next for you? I know, sending hello there might seem a little trivial, but that exact pattern, send, receive, process, delete, that is the fundamental building block for creating systems that are incredibly tough and can scale like crazy. Because now, when your services are decoupled, your image processor can crash, it can restart, it can get totally swamped with work, and the web server doesn't even know or care. It just keeps dropping messages in the queue, totally confident that they'll get processed eventually. And once you embrace this, it unlocks a whole world of amazing architectures. You can have messages in an SQS queue automatically trigger an AWS Lambda function, creating these slick, serverless pipelines. You can use queues as the communication backbone for a whole fleet of microservices. You can manage massive batch jobs. Or, and this is a big one, use a queue to absorb a sudden flood of requests to stop your database from falling over. The possibilities are just endless. So I'm going to leave you with this question to think about. Take a look at the system you're building right now, or maybe the one you're dreaming up for next. Where are those fragile links? Where are things too tightly coupled? And how could putting a simple message queue in the middle not only make it more reliable, but maybe even make it simpler for you to build and manage? And that's our look at Amazon SQS. If this explainer helped you out, do me a favor and hit that like button, share it with a friend, and subscribe for more deep dives into the tech that powers the cloud. Thanks for watching.